Okay, now let's do piecewise defined functions. This is one of my favorite things to do, which I know I say that a lot and everything. Algebra is one of my favorite classes to teach. So, and I know that this is algebra and and calculus, but I love this course. So let's go into how to graph these functions. And my advice is to graph a piece at a time, is to take it part by part and just do it a little piece by a little piece. So what we're going to do is, for the first part, we're going to graph y equals 2x plus 3. And what we need 2 points. And so first we're going to look at x equals 0. And I realize that for this side of the graph, 0 does not exist, but it doesn't matter. We still need to find out what that value is on that side of the graph, so we're going to graph it on that side. So if we let x equal 0, then we have y equals 2 times 0 plus 3, so we get 3. So we have the point 0, 3. Now, we know that it is an open circle because x is not equal to 0. So this is an open circle. All right. Then we're going to let x equal to -1 because we need a second point to graph a line. So this means that y equals 2 times -1 plus 3, so that's y equals -2 plus 3, so that's 1. So we have the point -1, 1. All right, and that will be a closed circle because it is less than 1. Because it's less than 0. So this is closed. Okay, now we're going to look at, and that's all for this line. Now we're going to look at the line y equals, and I'm going to rewrite this as minus x plus 3. All right, and again, we're going to let x equal to 0. Then we're going to have y equals 0 plus 3. So that gives us the point 0, 3. And that's going to be a closed circle because we have x is greater than 0. And then we're going to use x equals, say, 1 because 1 is greater than 0. So then we're going to have y minus equals -1 plus 3, so that's 2. So we have the point 1, 2. So now let's go up here, and again that's closed because that is greater than 0. All right, so now we're going to go over here and we're going to just graph this function. All right, so we have the point 0, 3 up here. So here's 0, 3. And that exists for both of them. On one side it's closed and on one side it's open. Okay, so it's going to be an actual closed circle. Then we have the point -1, 1, and it's closed. So this is -1, 1. And so then we have the line going down like this. And this is the line y equals 2x plus 3. And then we have the line over here. We have the point 1, 2. So we're up here at 1, 2. And we have a line going down here. And this is the line y equals 3 minus x. And there's our graph. And that's all you do. So you just take it a piece at a time. This function is actually continuous. It's continuous because both lines go through 0, 3. All right, now let's look at number 18. So again, I'm going to take this little section and I'm going to split it in half so that I can do each of these points, each of these lines. So we have y equals minus x squared plus 3. Okay, and so we have a vertex of 0, 3, and we open down. Okay, and this is on the right side. I'm sorry, on the left side. So this is x, this is y, and I go to 0, 3, and I have this right here is open. So I go to 0, 3, and I have an open circle. And here I have y equals negative x squared plus 3. So that's that one. Then I have on the right, I have y equals x squared plus 2, and that is a vertex of 0, 2, and it opens up, and it's on the right, and so I go to 0, 2, and I'm a closed circle, and this is y equals x squared plus 2, and that's my graph. This function, this is discontinuous because these two are not the same. Okay? So now let's look at 19. So for 19, I'm going to break this into 3 regions. Okay? So I'm going to draw a little break down here, and I'm going to break this into 3 regions, one for each graph. So I'm going to have my x is less than or equal to negative 2, and that's going to be y equals negative x squared plus 4. So that has a vertex of 0, 4, and it's down. Okay, so now I'm going to go ahead and I'm going to draw my graph. So that's x and y, and at negative 2 I have an asymptote. So this right here is x equals negative 2. And then I have another one at x equals 0. All right, so this portion right here is between negative 2 is less than x is less than 0. So that's going to be what's right here. So, but let's go ahead and graph 0, 4. But 0, 4 is over here. I don't care about that. Let's look and see what happens at negative 2. So if x equals negative 2, then what is this function? Then I have y equals negative, that'll be 4, plus 4. So this becomes y equals 0. So I have a 0 here, and that's closed. So I'm going to be 0, a closed circle right here. So this is negative 2, 0 right here, and it opens down. So this is y equals negative x squared plus 4. All right, so imagine that it went all the way up here would be where my vertex is, but I don't care about the portion of this that would be up here. All right, I don't care about that part. Okay, now let's look at the line y equals x plus 3. All right, so at x equals negative 2, then y equals negative 2 plus 3 equals 1. So I have the point negative 2, 1, and that's open. and at x equals 0, then y equals 3. So I have the point 0, 3, and that's also open. All right, so at negative 2, I'm 1, and I'm open. And at 0, I'm 3, and I'm open. So I have the point 0, 3, and I have the point negative 2, 1. And so right here, I'm the line y equals 3 plus x. All right? Now, at x greater than or equal to 0, I am y equals x squared plus 1. My vertex is 0, 1, and I open up. So I'm at 0, 1, and I'm a closed circle, so this is closed, and I open up. And so this is y equals x squared plus 1. And so that's what my graph should look like. Okay, now let's go back over here and let's do the next one. So I'm going to go ahead and draw my axis, x and y. I have x is less than negative 1. So I'm going to go ahead and put in my asymptote. So x equals negative 1. I have another one at x equals 1. So I have negative 1 is less than or equal to x is less than or equal to 1. And I have x is greater than 1. Here I have y equals 2x plus 1. So if I let x equal negative 1, then y equals negative 2 plus 1, which is negative 1. So I have the point negative 1 with an open circle. Now I'm going to let x equal negative 2, then y equals negative 4 plus 1, which is negative 3. So that's negative 2, negative 3, and that's going to be closed. So let's go ahead and graph that line. So I have negative 1, negative 1, and then I have negative, oh, wait. Okay, so I have an open circle right here at negative 1, and then I have negative 2, negative 3, and so this is a line y equals 2x minus plus 1. All right. Here I have y equals 2x squared plus minus 1. So I have a vertex of 0, negative 1 that's up, and it flattens out kind of faster because of the 2. Actually, it grows faster. Sorry. The 2 makes it grow faster. All right. And so let's go ahead and let's look at this. So at x equals negative 1, then I have 2 minus 1, so y equals 1. And at x equals 1, then I have y equals 2 minus 1, which is 1. So I'm 1, 1, and negative 1, 1. All right, so this gives me negative 1, 1, and 1, 1. So I have 0, negative 1, and that's a closed circle. You're negative 1, and these are both closed. All right, and I have 1, 1, and I have negative 1, 1. There. All right. over here I have y equals minus x squared plus 1. So that's a vertex of 0, 1, and it opens down. At x equals to 1, I am then y equals 0. So I have 1, 0 down. And this is open. So at 1, 0, I'm an open circle. So this is 1, 0, and I go down. And this is y equals 1 minus x squared. And I did not write that. This was y equals 2x squared minus 1. So there is your graph. All right? And what you see labeled on my graphs is what you need to have labeled on your graphs. Okay? All right. Now, let's talk about how to look at a graph and get information off of it. So if I want to find the domain and range, imagine putting your left hand here and your right hand here. And to find your domain, what you're going to do is you're going to pull these down to match and pull this up to match your x-axis. And that's going to tell your domain. And if it flattens out to match your entire x-axis, then your domain is all real numbers, which this one does, because even this open circle gets filled in with this hole. All right, and all of these will fill in the x-axis. Now, to find your range, you're going to pull this down. So you're going to pull this way. So that's your domain. To pull that way. So that's your domain. Now, for your range, this is your range. So for your range, you're going to pull it this way. Now, this is going to go all the way up your y-axis. And this is going to come all the way down your y-axis. So your range, again, is all real numbers. Now, remember that you can write all real numbers like this. Just write it out. You can write negative infinity to infinity, or you could write what's called a bolded R. So that's 2 lines on the back end of the R. All right, to find where it's increasing, decreasing, or constant. Okay, what you're going to do here is you're going to put your pencil or pen on your graph and you're going to color it in. You're going to trace your graph. I'm going up, so I am increasing from negative infinity to negative 4. Okay? Now I'm going down. So I am decreasing from negative 4 to negative 2. Now I'm increasing again. So I'm increasing from negative 2 to 3. So I'm going to put the union symbol, which is just a U without the tail, from negative 2 to 3. And I'm decreasing again from 3 to 5. So I put the U and I put from 3 to 5. Now I'm increasing again from 5 to infinity. So I add another u to the increasing and I put from 5 to infinity. And since there's no constant, I like putting a little bar there that says, hey, look, there's no constant. Now, the relative maxima are where the maximums were, where I hit my highest point. So I hit a highest point at the x and y value are negative 4, 8, and 3, 6. I hit a relative minima at negative 2, 3, negative 2, negative 4, and 5, negative 2. I was discontinuous at x equal to negative 2. That was the only place I had to actually pick up my pencil. Okay? So, and then the function values at 5, at f of 5 is negative 2, and the function value at negative 2 is 3, and that is because that's where the closed circle was. And this is because that's where the closed circle is. All right? So, please let me know if you have any questions over this. You will see these types of questions again.